Hey everybody, this is Larry. This is me going with Q4 of the weekly contest for one. Yeah, maximum total reward using operations 2. But for that, yeah, I refer you to Q3. Definitely check out that video. Make sure you understand it. I just go over the dynamic programming structure. And the one thing that I talked about in the dynamic programming structure, ooh, this is the wrong one. Is this space optimization. But there's another way to think about this. There's another way to write that DP, something that I am not, the bottom up version, the optimized one. But there's also a different version of the space optimized one, which is that, yeah. And this is actually, if you think about the space optimized one, this actually becomes a very constrained, like a version of knapsack, a pseudo polynomial, where basically, yeah, you could see me writing it this way, but I'll do an optimization in a second. But the idea here is that you have a set with 0 because 0 is always possible, and then for each k, you just add it to everything that is true, which is the p less than k thing, right? P being the p for previous, but so for everything in the previous thing, which is the possible rewards, or the possible totals, maybe another way. So the possible total is less than the current reward, then we just do this thing. We have this thing just so that we don't go over too much, but I don't think it's even that necessary maybe for this particular problem. But yeah, but it's just a little bit cleaner so that, it bounces thing, but I think you could just remove it without carrying it. Yeah, but so okay, so this works. This is but for Q3, this is not. So I even submitted for Q3, but it's a little bit too slow for Q4 just because this is a lot of things, right? But another way to think about this is actually, and the sorting, I don't know if it's necessary anymore, but well, I mean, to get the max, you could get the max another way. But yeah, another way to think about this is, like I said, a version of knapsack, right? This just to be, let me actually step back a second. So this idea comes up randomly in places. It is a very common way to do this like on off thing. At least nowadays I've seen it more and more. I think Alex Rice kind of did it a lot, and and he just kind of rubbed it off me. But traditionally, the way to do it traditionally with pseudo polynomial knapsack is going to be something like this, where you could say for k in reward values, so maybe your DP will be like DP is equal to force times what's it, n times k, right? Is it n? No, it's n. I'm just trying to think whether it's n or n plus 1, but yeah, max plus 1, right? So this is like I said, the pseudo polynomial solution, right? So then now for k in values, which is for index, you can, I guess I have to enumerate this, or like for I in range of n, if you want to write it more traditionally, right? And then now, so what are you maxing, right? So, and dp of 0, 0 is equal to true, right? And then now, I guess in this case, then technically I think I have to do n plus 1. So then this is like, or something like this. So then now dp of I plus 1, and I forgot the other index, right? So then now we have reward value sub I is the current value, right? So then, and what are we trying to do? We're looking at everything that is v or less, right? So for j in range of v, so it goes from 0 to v, so dp of I plus 1 j is or equal to dp sub I of j minus v, right? So basically this is very this is something that happens a lot in pseudo polynomial knapsack, so I'm not going super in detail about this. It's just the way that I would think about it, right? Yeah. Oh, and this is I messed up already because max is actually 2 times max. Yeah. Yeah. Right. I messed this up too. Actually, sorry. Give me a second. What am I doing? J. No. It's J plus V is equal. Okay, there you go. Right. Sorry, I had the signs. Or I put in the wrong place. But yeah, but this is saying that if I and J is good, you do this thing as long as the total is less than V, right? But that is why we. It's kind of it. There's an if statement in the previous version, right? But the reason why we don't have an if statement here is that because we're bound to V, so every J is already less than V, right? And J is the previous total, right? Because the I index is just the index of the reward values. J is the previous total and whether it is possible to reach that total. And then now J from 0 to V minus 1, we're going to add it to here because it's always possible, right? And then now, yeah. And then really it's just, best is equal to 0, right? Maybe if dpi plus 1 j plus v is true, then best is equal to max best j plus v. Maybe something like that, right? And then let's give it a spin, see if this works. Okay, one time I plus 1, that one should be good. This also should be good. What am I doing wrong? Ding dong dong. That is curious. Curious. Which one is the out of bounds one? This can only be v times 2, right? Did I do this wrong? This sort. Which one is the thing? I is n. No, this. Oh, wait. Oh, I messed up anyway. No, this is right. The indexes are right. Where am I messing up here? Sorry, friends, technical difficulties. Okay, so I'm missing n. Did I do the index? Oh, I swapped the index. I'm just being dumb. Okay, so such a new mistake. Sorry, it's really late here in the East Coast in Columbia, South Carolina. It's 3:40 a.m. I'm trying to finish this while I can. So yeah. Okay, so this doesn't work. Why am I? Oh. Wait, no. That doesn't make sense. Why is this 1 1 1 1 1 0? So J is gonna be 0 all the way to V, so that's how it felt. Alright, let's just print. Alright, sorry friends, I have to debug a little bit, but I think this would be, yeah, like this is the way to teach it, but I'm just trying to think. Alright, because the 0 moved. Because it should be, why? Oh, yeah, no, I know. Okay. I forgot about one part, which is also that we want to copy all the things that we've done before. So we want to do something like yeah, like dpi plus 1j is equal to dpij, right? Maybe just do this, but and you include v, and because we're doing sorted order, these are all the possible. That's not true, is it? Whatever, I think we can just do times v plus 1, something like that. Yeah. Give submit. I skipped ahead a little bit. That's why. Wait, is this Q3? Is this too slow? Nope. I mean, this is a little bit sloppy, but it's not too slow. But yeah, but this is basically this is still Q3 constraint, so that's why it works. But the constraint, you can see that this goes from n times 2 times 3 plus 1, right? Which is still max, which is still not enough for us. But this is how you would do pseudo polynomial knapsack dynamic programming, which is very standard. And another way that you could do this is actually really clever, is that you can do it with one array. So you don't do this, you just do this. And the way that you do it is noticing that this only goes up. So as long as you do it in reverse order, then actually it is good enough. Yeah, and you don't need this anymore. Yeah, because you do it in reverse order, then you don't overwrite anything. You only do the things that oh, I missed an index again. Where? 3 minus 1 plus 3. No, that's right. Oh, I just forgot to take out this. Okay, whoops. I'm just really silly. So this is a one variation of the space optimization by rewriting it looking downwards and then optimizing out. I'm not going to go over it too deeply in this one. This is something that a lot of people know about for knapsack, but it's also not that commonly known if you're new to knapsack things. But yeah, just changing the order, now you have a one-dimensional array. And then the thing to kind of play about this now is that you can see that this is just, this is a plus 3, so you could see the shift and add action, right? And what I mean by that is just that if you look at it in a binary kind of way, which we do because it's false true, what we're doing is that we have, let's say we have, well, 0 is always going to be true, then false, something like this. I don't know, I'm just banging, so it's not real. But yeah, but next time, let's say you want to add the number 2 to it, then what happens? Well, if you look at the way that this is constructed, and we don't even need the space optimization, but then it's just this, shift by 2, right? Because you're adding 2 to everything. And then that means that these are all true. And then you now merge them back together in an OR kind of way, because all it has to do is true once, so then this just matches it this way, right? Whatever it is, right? So that's basically the idea about this, is that you shift and then you do an OR with the operation. I'm not gonna lie. During the virtual contest, and you could watch this, I saw this idea pretty quickly, but I didn't think it was fast enough. And I even said out loud, and you could watch this, I said, oh, that would be cheating though. So I don't think that's the answer. And I don't think it's cheating in the same sense that like it's cheating, but I thought that there would be a beautiful solution that I just didn't know. And that like if that worked, that would just be a way to kind of like, oh, maybe Leetcode didn't intend it to be this way. It's just that there was this performance thing that makes it fast enough, which is not like an interesting problem, because then now it's just like using a library is not an interesting problem, right? But it turns out that is the intention, as far as I can understand. And I didn't even write this code very cleanly. I was just a little bit, I don't know. It's just that using shift and add, and that's basically the idea. This is all is converting. So this true false thing I have here, I just convert it to ones and zeros as you do to binary numbers or true false, right? So yeah, and I don't want to go over bitwise things too much, but that's basically the idea, and this is why it's crap. But yeah, but seeing as you go to 1, you can think about it as just 1, but keeping in mind that this is the 0th index. I kind of wrote it in reverse. So you can maybe think about it here. Seeing as you go to 1 is actually, I don't know why I wrote it that way actually, is you go to this, and that just means that the 0th index is always true, as we can always make 0. And you have this thing. To dissect this, This part, 1 shift k minus 1, well, why does this work, right? It's just that basically for k, we want to take the first k minus 1 digits, right? And so basically this part just goes to, let's say k is equal to 5, right? Then this part will get 4 digits, right? Or no, maybe 5. I don't remember. Yeah, no, it should be 5 because it gets to 6 digits and minus 1, right? Because it shifts 5, it goes to this, and then minus 1 to get to all ones. So then now you have 5 ones, right? So that's basically the idea behind this part. And then this part is just saying, okay, what is the original number seen? So I don't know, maybe seen could be, I don't know, there's a lot of numbers, right? Maybe just mix it up a little bit so it looks random. And then maybe k is equal to 10, right? Less than that, say. Let's just say 5 again. So then now, this thing is going to be, as we said, 5 ones at the end. And this is seen, so let's line them up real quickly, right? So this is seen, and this is the 5 ones. And then this end statement just makes it so that all the ones match up and then all the zeros match up, but also that the prefix is all zeros. So then all you are left with is the last 5 digits, which is this, right? So now you get this as the result. I'll put a dash on it so that it's kind of, you know. So then this is what you get from that. It's just saying for each bit, if you, I want to chop up and only look at the first 5 bits. And then now the shift bit is probably the most straightforward, which is that is this shifted back k times, right? So then now, for example, if this is still 5, then this just makes it so that now it shifts 5 spaces. One less, one fewer, I mean, and then just zeros, right? And then now we all it back. So then now we have this number, and then we have this number, and then now we just do a OR. And this is what it sounds like, because now the zeros could become true if it is possible. And yeah, I know that I'm possibly going pretty fast, right? But again, this is not that interesting of a thing. I don't know. I think this is a very ridiculous problem, and I spent like 40 minutes just because I didn't believe this was the answer. I was trying to think of a better answer. Oh, and then I guess I skipped the last part. And the last part is just, and I didn't even, there are ways to write this more cleanly, but I was just lazy. This is just saying, okay, let's just see if the, you have a number of a lot of digits. Let's just see, is this a 1? No. Is this a 1? No. Is this a 1? No. ... And that's basically how I do it. You could do this you could write this in a number of ways, right? To get the biggest one, but this is how I do it. I don't know. It's not that important, to be honest. I mean, I guess it's important, but I just don't care about it. And the reason why I don't care about it is this is just a crappy problem. Like, the problem should not be, hey, do you know what bit set is? And the constraints are such that there's no problem solving. Like, I don't know, I'm not that interested on this one. Like, it's just random library things that you should know that is fast enough, right? Because the thing is that, like, this looks cool or whatever, but still, the complexity is technically the same, right? Because seen has n digits, n binary digits, or not n, sorry. Seen can have at most max, so let's just call it max. Seen could have at most max times 2 number of digits, right? Or minus 1 or something like this. But yeah, right? And if you think about digits, then yeah, it's going to, so it is technically, yeah. And this operation, well, the OR thing is linear in the size of digits, so it's going to be mx, or max. This bitwise n is also max number of digits, or technically k number of digits or something, but like, O of max number of digits, or not, when I say, no, it's O of max number of digits, binary digits, right? Because it takes, we have one, like if max is 1,000, or in this case is 5, is it 5,000 or 50,000? 50,000, then seen could have 50,000 digits, right? And in this case, this also uses 50,000 digits time, roughly speaking, and this shift as well, right? So all this is going to be all of mx time, which is number of digits, and this is all of all of n times, right? So this is going to be actually all of n times max. So time is still all of n times max time, and all of I guess mx space, right? Because scene can be 2 times max, and that's fine. And this is exactly the same complexity as this one, right? It's just that, yeah, it's just that they want you to do this silly optimization and think it's good enough. And that's the thing, right? Like I don't mind grinding and spending 40 minutes and learn something really cool and new, but I've learned nothing, right? I mean, like, you know, maybe not immediately, but I got this idea very quickly, but I thought it was cheating because it's just not a way, like it's just a silly solution, even if it's true, and it turns out to be true. I don't know what else to say about this one, but definitely, but yeah, that's the progression from here to here. And that's how I think about it. Anyway, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, do good mental health, and you can watch me solve it live-ish, because I don't know, a lot of it is just me trying other solutions that don't work. You can watch me doing that now. Okay, and then now Q4 is now we're doing the more interesting part somehow. Really behind. That took half an hour of silliness. I just think today, some days you're just having rough days, and that was one of them. Okay, so is that just to make sure that that's the only thing that's different? Okay. And I'm like really struggling on time, so I really need to get the Q4, which a lot of people got apparently. Okay, okay. So we're still sorting. That makes sense. How do I get it in? How do I do it faster? Let's look at this function. Oh, not this function. Let's look at this function, right? This is pseudo polynomial, which we cannot do anymore. So this is 50,000. And I don't know that I can do the same technique I did with the bi-weekly. This is not a good day for weekly. This is not a good weekly anyway. The day has been beautiful. What am I doing? Why was I so dumb? Okay, I think. What is the harder way of doing it? So we're maxing over the possibility of these transitions. But is there something not DP about it? Is it still DP, and is it a DP optimization? What does the path look like? The path is just it should be all the numbers that are up to it. And actually, now that I see it, I'm like this. I should have done this one much quicker. There was another way of doing it with a for loop, but then now, how do I do it that way? Can I abuse it that way? Like another way to write this might have been like this. I'm just doing this right now to kind of brainstorm ideas, but something like for hey, values, right? And now for P and scene, right? So these are the previous values. If P is less than K, then yeah, and then we have our next set is equal. Yeah, and then now next we add P plus K, right? And then now scene we added to next, and then we just kind of, I mean, it's something like this, but not quite, because we have to do the thing where best is equal to 0, and then we put p plus k. If p plus k is less than the max, then we do this. Else, then best is equal to max p plus k, and then we just return max of scene or max of best, something like this, right? That's also n square or whatever. Maybe if I'm not right. Set plus set is not. Is that not a thing? Oh, is it wrong notation. Yeah, okay. And this is much faster, maybe. At least even in Python, that's good, right? So I forgot about this idea, and I did it the other way. But now, can I read? Does this help with the 50,000? No, because there's 50,000 numbers, and you have to go through 50,000 times. But can I think about this in terms of what does this look like? What does the growth of this look like, right? I think I need some visualization. So let's say we have, well, maybe I'll just do that. Let's take out these, put the cases in here for now. But maybe like 1, 2, 3, 4, and then just print scene. It's gonna skip this stuff with the things though, but so maybe I'll just take that's not really illustrative enough. But what is the? Because I have some idea about like thinking about them in terms of line segments or something. I guess only unique things matter, right? Because I mean, but that's just like a very minor optimization because it would just be all different. But it reminds me of so basically you're taking a segment and then you're adding it. So you have how do I say it? So for all the segments under, so now it becomes another thing of for all numbers under k, add shift it by whatever. I'm trying to honestly, I'm trying to think whether there's like a segment tree solution for this. Because you could definitely do the range. It's almost like yeah. So there is a matrix operation on this, but the matrix solution is also too slow, right? Because you could do a matrix transformation and then do a set of those things. A binary matrix of, okay, yeah, you could do that, but that's still too slow, unfortunately. But that's a very cool way of doing it, though. But okay, so then let's say you have one. Yeah, okay. What? Yeah, okay, fine, it's not list. Oh no, it is. And then the 20. We'll do a query on these and then add 20, right? And then some of it's stupid, that's fine. Is there another data structure that I could do? How much time do I have left? 54 minutes. This reminds me a lot of like I almost feel like there's like a fast Fourier transform thing about it, but that's, I'm not gonna go there. Because shift and combined, which is kind of what I have here, so shift and combine, but that's not good enough. That's not fast enough. How do I reduce that time? How do I get rid of the decision? Am I doing it wrong? Can I count backwards? 20. It's not greedy. No, it can't be greedy. But is there a way to do it backwards? Man, I'm gonna be sad if this was another segment tree thing that I don't know about. Shift and add. What does that remind me of? Shift and add. It only shifts some subset, right? So I mean, I wonder if I could do it like cheat and do big int and see if it's fast enough. But that's not even like, that's just cheating anyway, even if it works. I don't think that's the idea. I was hoping for a quick solution, but man, this is day and night. I need. How do I even draw edges? So this works in Python, but how do I need to be better about this idea. I think this idea, every time I'm like a little bit slow on it, but so once you see a number, it's there forever. It reminds me a little bit of coin change or something, but in some way. No, that was there's a problem that's like a maximal sum of things. No, there's no, I mean, is there a way to? No, and you can't do greedy because, for example, you add the number 36 and 36 wouldn't be good enough. So you can't take just a subset because all of these can be a number that you add to in the future, which means that that'll fail greedy by default. $50,000. $50,000. So it's like divided by 8 is, no, 8 is, so what was 50,000 divided by 32 for an int? And for each number, each number 2,000. No, that's still too slow. It's 50,000 times 2,000. No. Missing an idea. Maybe it's not something that I can just optimize away. I mean, unless it's square root decomposition. Is there a square root decomposition? No. No, you need the decomposition. It's not seg tree, prefix tree. Thinking of crazy data structures, I'm trying to think whether there's like something more basic. Like line segments, but then we just keep on. It does remind me a little bit of union find in some way, but still you have so many individual components, and if you multiply by, if you don't have even, or if you have one odd number and all even numbers, for example, they will never merge and it will never be fast enough. How do you do it? Well, Well, the numbers that store only 20 cares about these, but then maybe about 21. So then, is there a way to store only the numbers we care about? No. Can that be effective? A lot of people got in this. I'm actually like kind of surprised. Oh, in 8 minutes even, stupid cheer. Huh. Am I missing something obvious? I mean, clearly, but missing something obvious for Q3 even. But and BetSim, well done. Even though they all do that weird trick now, but what am I missing then? But they all know Sigtree now, so. I'm not gonna lie, I'm looking up segment tree to see if there's something like I don't know about segment tree. I don't think so. Well, I mean, there's a lot of things I don't know, but I don't. I don't know that I think so. Alright, maybe something more fundamental. I am really struggling on this one. What does max mean? So, okay, if it's not a set, let's say we have an array of 2,000 booleans and we just shift and, right? Even that is, I don't know why I'm so bad at it, but let's say about that. How do we, going down, I was trying to think about going downwards. I don't really see anything obvious about going downwards. But a lot of people got this by now, so I don't know. Am I missing something on this one? I don't think so, right? That'd be funny if I was looking at the wrong problem the entire time, but no, it's just a constraint. It's 50,000, right? Yeah, I didn't misread it. It's still like a binary search. What are you gonna do? Well, the number can at most be 2 times max, but is there a binary search I can do? No. What about the reverse? What do we do with the fact that 2 is not possible? Is there a pattern here? There is a pattern here, kind of, based on the fact that, okay, so there's a gap of whatever. There's a 4, but this is a 9, 4, 4, 9, so that doesn't even make sense, right? So this is 1, 4, 1. Right, so it's 1, 4, 1, 1, 4, 9. How do you even get 9? Oh, it's just 15. So okay, but so it's 1, 4, 1, 9. How can that even be used? And then it's just the same, right? So you could do like some recursive thing on this structure, maybe. And what happens if we do 20? Yeah, this just, I don't think that works. Okay. How much time? I'm making mistakes left and right on this contest. Used all my juice on brain bi-weekly. Brain juice on bi-weekly. Okay, so this takes the 20 takes the max that's less than 20 to get 36. But then what does that mean? Can I figure something out from this 36, right? Because the next number could be 30, or even just like 25, right? Then we take 21 and then add 25, 40. But they can be any of these numbers. Like the next number could be any smaller than it. So you could force every number to be used, so you need every number. My bags of tricks are not sufficient. This was the other one. Oh, okay, let's look at the Leetcode, the Python version. Is anything to optimize? No, I don't think there's anything to optimize here. There's nothing to make, because this is a fundamental thing unless we're able to reduce it somehow, which I don't know that I can know. Also, we can make it faster because only the set values matter. So this so the worst case is that they're all different. What happens when a number is missing? When you take out a number, is there a way to handle that? Think of it that way. Can you take out a number? Here we took out 2, say. Because 1, 2, 1, 2, 3 has all this. When you take out the 2, we've taken out the 2 and the 5. And there's really no other way to get the 2, right? That's not even, how would you even get 5? Like, I mean, I know it's 2 plus 3, but you can't even like go to the bounds of it. This really reminds me of that, like how much possible, or what's the maximum amount you can make with this denomination problem, but I can't figure out how. Or like not max, but without gaps or something. It's that idea of, no, but it's different, because that one you deal with adding spans, and then therefore you have a greedy span on top. But this isn't quite that, right? Right, so let's, for example, let's look at right, and eventually all the gaps close, so because of 6 is getting filled in. So I don't even know. No, we don't need the thing here. But what is this case? Oh yeah, that's just 2000. Yeah. It's just so if everything is filled, then it's just the biggest 2 numbers. So that is the upper bound, which we knew kind of, but is there another specific way? For example, if we find a set of these, is there like okay. the case where, okay, let's play around with the counter example, right? So you have one, let's say 1,000, but something like, now this is still 150. Wait, yeah. First, how do I put that? So then now, if we have, okay, let's just say we have so something like this, yeah. Oh no, it still has the biggest two numbers. Is the biggest two numbers always in it? I mean, I have to say definitely not, right? But, and what does that tell me if the biggest, like, can I abuse that in some way? How do I abuse it? How can I find a way to do this without the biggest two number? So maybe I have yeah, I think that's right. Oh no, that's still wrong. Whoops, I need something like 100 or 99. Yep, okay. Well, even like, okay, so yeah, so we don't use the biggest two numbers always. That's what I mean. I kind of knew that, but I was hoping that maybe that'll open an avenue, just exploring. I'm still trying to figure out. Like I feel like I'm missing either one probably or one data structure, and I have no idea how to do it. What am I missing? Try to figure out how did I get 50? Is there it still feels to me something that I don't know. Is there a way to do shift and add in a faster way? Or am I like thinking of some weird things? And that's effectively what I'm doing, except I'm doing one bit at a time. But can we shift? all the bits at the same time. But even then, I don't know. That would be a really fun solution if that was the case. But now, because even adding would take all of n number of digits. So that's still, I mean, but that's like a very fast n square. I don't know. I feel like that's cheating anyway, even if it works though. I mean, I have nothing better to do, so how would that even look? Oops, let's do it here. I don't even need to sort it in this case, in that case, but is that right? Yeah, maybe. How do I get the max thing again? I don't even know. I'll just be too lazy because I'm just playing around. Does this work? Nope. Why is that not? Is this not right? Just order. That's k. Okay, it's more than k. The 0th bit is 1. Am I just, and then that's weird. Let's just see. Don't try this at home, kids. Why is that not right? 3:15:63. Okay. Oh, this should be 2 times this anyway, but whatever. I'm just being really bad right now, I suppose. Oh, and this is going down. That's why that's the other reason why. 11, 11, 195. Is that right? Oh, yeah. Yeah, I think that's right. All right. Let's YOLO submit. So that still works, but let's say we have was it 50,000? I mean, this would be really funny, so I'm just gonna submit it. But I don't know. I don't know how to do it. Feels like some sort of like, I don't know. I mean, I think this, it will time out, but it would just be funny. I mean, I don't think that's the solution though. If that is the, I mean, like I talked about this earlier, but I don't know. I mean, I talked about this earlier, so I don't know that I wanted to count that. But like, because I would have gotten that in like 10 minutes, but I don't know what the real solution is either, so I don't know. I think I am so tired from, so I'm gonna spend like a couple minutes. How much time do I have left? 20 minutes. I'm gonna spend a couple minutes and then we'll see. But I don't know. That's just weird. That's I don't know that they can fix it either. But and you could maybe even do something like just to kind of make it whatever, but oh, oops. So this is even faster, but I'm curious about the timing. Yeah, I don't know. I mean, they could definitely add more cases and eventually time it out, but I don't know. I don't know how I feel about this. Thanks for watching, everybody. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.